welcome to my ELM test prep series. I'm James S., and this is a series dealing with preparation for the ELM test entrance exam for universities and colleges. This episode, episode 31, is about ratio and proportion. In general, a ratio implies two numbers. A proportion implies four numbers. So there's a little bit of difference between them, although not a significant amount. So, what would be a typical ratio that we might run into? Well, I might be mixing some kind of drink or some kind of solution, and I might mix 2 parts of something to 3 parts of something else. So my ratio would be 2 to 3. Another way to express that is 2 over 3. I have 2 parts to 3 parts. I have 2 of the parts to the 3 whole parts needed. Okay, so there is a relationship between the idea of a ratio and a fraction quite often is called a ratio, and often you'll run across the term a rational polynomial. It's nothing more than some algebraic fraction or algebraic ratio. Okay, rational polynomial, ratio, fraction, those are 2 words that you could use almost synonymously. So, let's talk about proportion. And I'm going to throw a couple terms at you like means and extremes. Somewhat technical. You do not have to necessarily remember those terms, the means and the extremes. Extremes seems to imply outside or to the extent, whereas means implies sort of in the middle. If we were to take the mean or average of something, we would look for what all these parts kind of boil down to in the middle. All right, so enough on how to associate those. Let's look at what we might say. Let's say we have 2 is to 3. Nice 2. As, and the 4 dots or 2 colons are read as an as statement. 2 is to 3 as 4 is to 6. And we said the extremes were the outside numbers and the means were the inside numbers. Well, as it turns out, the means equal the extremes. So 3 times 4 is 12, and then 2 times 6 is 12, and sure enough, they do equal each other. And that is typical of the way you would work a proportion based on that idea that the means equal the extremes. All right, the inside pair multiplied equals the outside pair multiplied. All right, so having attained that wonderful piece of information, let's look at another way of thinking about this. Well, we said a ratio was equivalent to a fraction. Well, I have a ratio here and a ratio here. Sure looks like it. So can I say 2 is to 3 as 4 is to 6? Well, it would seem so. If I double this, I get 4. If I double this, I get 6. So they are, in fact, equivalent. So how does that relate to my means and my extremes? Well, notice 3 and 4 were my means, right? And there's my means, and there's my extremes. Well, as it turns out, if I cross multiply, I will, in fact, get the same number. 6, and let's just do that. Let's multiply both sides by 3. And so this would go away, and then I get 3 times 4 is 12 over the 6. And then I'm going to multiply both sides by 6, and that'll cancel, and this will be over here, so 6, so I get 12 and 12. So if I want to check to see if a fraction is in fact equivalent, I would cross multiply 20 and 21. So these are not equivalent, so they are not equal. A quick way to check if two fractions are in fact equal to each other or proportional to each other, just do a quick cross multiply. All right, let's look at an application of proportion. Quite often we get a problem where we have been given two triangles and they say that they are similar or approximately equal to each other. What we're saying is the angles are equal to each other, but the sides are not. They're in some kind of ratio to each other. I could say that 3 and 4 and 5 and x, and I would be looking for the value of x. So I could set up a ratio or a proportion here. I could say 3 is to 4 as 5 is to x. Well, the insides are 20, so 3 times x would have to equal that. Dividing both sides by 3, x equals 20/3. Now, it didn't come out even, but I was able to quickly come to the solution, even though it wasn't quite clear. Now, the ratio between these two is not exactly clear either, but it looks like it's 3/5. All right, so let's talk a little bit about the idea of equivalent angles. This is sort of a fancy word for equal to. So if this angle is 35 degrees, then this angle would be equal to 35 degrees. Well, if I have this angle here, it doesn't really matter how far out these lines extend. It's still going to be 35 degrees between the two lines. So if I were to drop a line down here, continue this on out, and then drop another line down here, if these two lines were in fact parallel to one another, and I want to take these arrows off here, if these are parallel, then this triangle is similar to the larger triangle, because parallel lines with a bisector will give me equal angles. And since I have my angles equal, my triangles are in fact similar. So I can do a ratio and proportion to various parts. Okay, we're running up on our time clock. I hope this was informative. We talked a little bit about ratio and proportion and how we can use that to solve some of our problems that we run into. Hope this was informative. This is James S., and this is my ELM test prep series. Have a good day.